Okay, here we go. So today's lesson is Intro to Matrices. I am recording, guys. So we're going to start with some definitions. What is a matrix? Technically, in the book, it will say rectangular array of values enclosed by brackets. And you'll see lots of examples on here. There's one over here in the next box. Always uses square brackets. An element is a single entry in a matrix. So basically, it's a single number that's in the matrix. And we'll talk about how we identify those in a little bit. So we watched a little video from Khan Academy to introduce some of this. We're going to do some examples, make sure we have some terminology down, and then I'm going to show you how to add and subtract matrices and do some scalar multiplication, the simple operations that go with matrices. Alright, so this part was in the video. Dimensions of a matrix are always given in the form rows by columns. So if I'm looking at this, there are 2 rows. So rows go horizontal, row, row. And then columns, there's 1, 2, 3, 4. So we would say that this is a 2 by 4 matrix. That is the dimensions of the matrix. Okay?
Like the actual matrix in the movie?
No, the matrix in the movie would have had millions and millions of entries because to do the kind of animation that they were filtering into people's heads with all the variations, that's why there were lots and lots and lots of numbers.
That's intense.
Okay, so when we do matrices, we give them a name, and you can identify each number using something else. So here's a matrix. It's the same matrix we just had. It's 2 by 4. I can name a matrix using a capital letter. So we're going to call this one capital A. Then if I am identifying a single element from the matrix, they will use a lowercase a. So it says find element A13. The 1 means it's row 1, column 3. So here's row 1. Here's column 3. And so this would be the entry A13. So I would say that that entry is -4. Okay?
So what if you have like a bunch of numbers?
If there's a bunch of numbers, then there's a bunch of counting. But most of what we're going to work with is not terribly big, because we're just trying to get the main ideas. All right, so it says, what is the element A24? This is telling you to look in row 2, column 4. So here is row 2.
It's actually 1.
Here is column 4. So that would be this 1 right here, and I would say that that entry is 1. So it's an address. You could think of it in terms of sort of latitude, longitude to find numbers inside a matrix. So it's not A13, it's not A24, it's A13 and A24. I will tell you, historically on the test, a lot of students miss this because we do it the first day and then they forget about it and they get to the test, they don't study, they miss these. These are easy. So you might just remember to look back at these before the test, which will happen in a couple weeks. This is going to be a short unit. All right, so we have some special terminology we're going to look at. In this first example here, I have only 1 row and 1, 2, 3, 4 columns. So I would say that this is a 1 by 4. And they sometimes refer to this as a row matrix. If it only has 1 row, they call it a row matrix because it just looks like 1 row. I know that's really super imaginative, but that's what they call it.
Let me guess,
So
that one's a column.
this one they would call a column matrix because it just looks like a column. And since it has 4 rows and 1 column, they would call that a 4 by 1. Okay, so moving along, what would be the dimensions of this matrix?
3 by 3.
This is a 3 by 3, and anytime these numbers are the same length and width, they sometimes will call it a square matrix. And there are certain things you can do with square matrices that you cannot do with other matrices that we will encounter, so that's that. And this is a matrix. This happens to be a column matrix, but it's also special because it's all zeros. So they call it a zero matrix. I know, it's kind of weird. And then it would have the dimensions 3 by 1. So just some terminology. We don't use a zero matrix very often, but somebody decided to give it a name, so we're just covering all of those definitions that you would see in a textbook. All right, so on the next page, we're going to learn about 3 major types of operations we can do with matrices. Okay? It's pretty straightforward. If you're adding matrices, you're going to add the numbers that are in the same position. So down here, we're going to write a note that they must have the same dimensions. So both of these are 2 by 2s. This is a 2 by 2, 2 by 2, it's okay. And the reason is you're literally going to go along and just add the numbers. So this is position 1, 1. I'm going to add the 4 and the 3 together. 4 plus 3 is 7. Then I'm going to take negative 2 and add 2 to it. You get 0. 7 and 5 is 12, and 0 and negative 3 is negative 3. So you just add the numbers in the same position, which is why they have to have the same dimensions. I can't add a 2 by 2 and a 2 by 3 together because I'm going to run out of numbers for one of them. It wouldn't have anything to add to. So they have to have the same dimensions. Same thing works for subtracting matrices. And I should also note that the answer has the same dimensions. So if we are subtracting, we do the same thing except that we will subtract. So I'm going to take 4 minus 3, which is 1. Negative 2 minus 2 is not 0. If I have negative 2 and I take 2 more away, it'd be negative 4. 7 minus 5 is 2. What about 0 minus negative 3? You're right, it is positive 3 because it'd be 0 minus negative 3. Changes it to 0 plus 3, which is how I get that right there. So this is my answer. If I'm subtracting a 2 by 2 and a 2 by 2, my answer is a 2 by 2. So a couple of more. So on this one, we have a couple column matrices. Same thing. We're going to subtract. So I have 12 minus negative 8. It's not. It would be 20. Good job. Negative 4 minus 19. Good. 13 minus 23.
Negative 10.
Good. Negative 10. And negative 7 minus 14
Negative 21.
is negative 21. So make sure this is a 4 by 1. This is a 4 by 1. The answer is 4 by 1. Sometimes you get a trick question like this. This is a 3 by 1. This is a 2 by 2. I don't have numbers in the same positions, so this one is not possible. And if you were asked why it's not possible, it's because they have different dimensions. And that is a question that will come up as we review. So basically, they have to have the same dimensions in order to add or subtract. Shh. Okay. All right, the last thing we're going to look at for this lesson is scalar multiplication. So this is called, the 5 that's out here is called a scalar factor. And basically what it's going to do is multiply by everything that's inside. You can think of it as distribution. So I'm going to take 5 times 6 and get 30. Take 5 times negative 1, negative 15. 5 times 1 is 5. 5 times 9 is 45. So this is called scalar multiplication, where you take a number times a matrix. Now in tomorrow's lesson, we're going to do matrix multiplication, where you multiply a matrix by another matrix. It is not this easy. There's more steps, but this is the one that is easier.
Ooh, this
Okay?
one is going to be tough.
All right, so this next problem that we have matrix A right here, matrix B right here, And they want us to find 4 times A plus 3 times B.
Oh.
So I would do this in steps. I would put a 4 out here and take it times all of these. So 4A, I would take 4 times negative 3, which is negative 12. 4 times 4 is 16. 4 times negative 11 is negative 44. And then we're going to add that to 3B. So I'll stick a 3 out here, and I'm going to take 3 times all of these. So 3 times 4 is positive 12. 3 times negative 7 is negative 21. And 3 times 13 is 39. So we do the multiplication first, just like you would with order of operations for regular numbers. And then the last step is to add them together. So negative 12 plus 12 is 0. 16 plus negative 21 is negative 5. And negative 44 plus 39 is negative 5. But for all of this, the answer should come out the same dimensions as the matrices that you're working with.